the important glands in our body. Okay, it's a very important gland in our body. The thing is that first, adjusting the amount of hormones, okay, regarding the thyroid gland is usually difficult. Sometimes thyroid gland looks normal when you look at the gland, okay, at the throat, it looks normal. Sometimes you check the hormones, okay, the results in the blood, okay, blood results, you check the hormones and it's still normal, but when you touch the gland, you will see it's abnormal, okay. So it's a very important gland. If you look at the gland, it looks like a butterfly. You can see it looks like a butterfly over here. It is situated on the neck, okay, on the neck of the person in front, okay. And as I said before, thyroid gland should always be touched, okay, for examining it. It should be examined, okay, to make sure that nothing is wrong with the gland. Because sometimes the hormones are normal, but the gland, it has got some problem, okay, that it should be solved. It's either hyper or hypo, is very difficult to come to know. If you see the thyroid gland, on thyroid gland, okay, these are parathyroid, PTH, or parathormone, okay, parathyroid gland, which produces PTH or parathormone, okay. And also there are some cells, okay, which are known as C cells over here, which produce calcitonin, okay. So thyroid gland. On thyroid gland, we have parathyroid glands, also calcitonin, okay, which is present, which we'll see this later on, okay. Now, thyroid gland, this is how, when they want to examine, okay, you have to put the head exactly right up, okay, right up to check the gland. Don't touch it, okay. You have to put it up, put your head up. It's a very sensitive gland. Okay, so don't touch your glands, okay? Okay, now this, the hormones which are produced for it, they're known as T3 and T4, okay? T3 and T4, yes. Now, these two hormones which are produced from the thyroid gland, remember, they are synthesized from amino acid tyrosine. So amino acid tyrosine is the precursor for synthesis of thyroid hormones. Very important. Okay? So amino acid tyrosine is the precursor for synthesis of thyroid hormones. Okay. So there are known as tetraiodothyronine and triamine, okay? And also we have synthesis of calcitonin and also PTH, which we will see this later on in the parathyroid discussion of parathyroid hormone. Now, for synthesis of thyroid hormones, we need iodine. Okay, so iodine is very important. We require iodine for synthesis of thyroid hormones. At the level of hypothalamus, we have TRH, or thyrotropin releasing hormone. Thyrotropin releasing hormone, or TRH. TRH acts on the pituitary, at the anterior pituitary gland for production of TSH, or thyroid stimulating hormone. Thyroid stimulating hormone acts on thyroid gland for production of T3 and T4. Okay? For production of T3 and T4. Okay, now, the precursor for synthesis of these thyroid hormones, okay, is a huge protein which is known as, it's a huge glycoprotein, okay, thyroglobulin. Thyroglobulin is a huge glycoprotein. From thyroglobulin, we start cutting, okay, and the hormones are released, okay. So thyroglobulin is a glycoprotein. It's a huge glycoprotein. It is cut and hormones are released. T3, T4, T3, T4. Is it clear? Okay. Now, let me go further. Okay, these are the structures, okay, of T3 and T4. Okay. T3, these are the iodides. Okay? Okay? 4 iodides on the structure. Okay? T4, 3 iodides, it is T3. Okay, this is how it is synthesized. First, remember. Now, look at this. If you see the cells, okay, which are there in the thyroid gland, okay, thyroid gland, there are some special type of cells which are known as follicular cells. In the center of this follicular cells, we have a cavity, follicular cavity, which is a colloid. Okay, so we have the follicular cells, and in the middle we have a colloid, follicular cavity, which is the colloid. Is it clear up to now?
Yes.
Now see, this is one of the cells. In these cells, in the follicular cells, first we have synthesis of thyroglobulin. We said thyroglobulin is what? Is a glycoprotein. It's a huge molecule, okay? So thyroglobulin is produced. Once thyroglobulin is produced, okay, before it goes inside the colloid, okay, over here, okay, it comes, it stops over here. Wait. Okay, now we have pumping of iodide against the gradient, okay, inside the follicular cell. Okay, so large amounts of iodide is pumped inside. Remember, the amount of iodide over here is too much as compared to outside. Okay, so it has to be pumped against the gradient. You know this gradient?
Yeah.
That means large amounts over here, little amount is outside. So large amounts of iodide, okay, it is pumped inside against the gradient. Iodide comes inside, okay, then you have the thyroglobulin over here. With the help of enzyme peroxidase, these iodides, they are put on the structure of thyroglobulin. Is it clear? So I have the protein being synthesized, okay? Now what happens? The iodides have to sit on it, on the structure. Is it clear? Okay. So iodide is pumped against the gradient. It goes inside the follicular cavity. Okay. Thyroglobulin is ready. Now what happens with the help of enzyme peroxidase? Okay. Coupling occurs. Iodide sits on the structure of thyroglobulin. Now this thyroglobulin, it goes into the colloidal phase, in the outside the follicular, inside the follicular cavity. Then again, whenever our body needs it, it comes back again into the follicular cell. Okay? Now it can, when it comes inside, okay, there are lysosomal enzymes. These enzymes, they start cutting. Okay? T3, T4, T3, T4, it is cut. So the hormone is ready. Now the hormone diffuses out, okay? It goes out, it diffuses out, and then it goes in the bloodstream and it goes to the body. Is it clear?
Yes.
Start repeat again. First we have synthesis of thyroglobulin. So thyroglobulin is synthesized. What is thyroglobulin? It is a glycoprotein. It is produced in the follicular cells. Is it clear? Okay. Now once it is synthesized, keep it aside. Okay, pump iodide, okay, against the gradient. Large amounts of iodide is pumped inside the follicular cells. Now this iodide, okay, is coupled with the thyroglobulin, okay, with the help of which enzyme? Peroxidase. Okay, now thyroglobulin, now it is iodinated. It goes out into the colloidal, in the follicular cavity. Whenever we need it, again, thyroglobulin comes inside with the help of lysosomal enzymes. We start cutting it. Okay? So T3, T4 is released. Now, T3, T4, they diffuse out to the bloodstream and they go to the body. They reach wherever we require them. Any questions? Did you understand? Yes? Yes? It's the same thing. Okay, skip. Okay, so T3, T4 is produced. Now, remember, the major hormone secreted, okay, all the time is T4. But which one is the active one?
T3.
Okay, so the major hormone which is produced is what?
T4.
T4. but the active form is
T3.
T3. Okay, so T3 is the active form. Remember. Okay. Now when the hormone wants to travel in the bloodstream, okay, it binds to its we've got usually what happens, we need a carrier molecule in the blood, okay? So it binds to either tyrosine binding globulin, it binds to it and it travels in the bloodstream, tyrosine binding prealbumin, or tyrosine binding albumin, okay? So these are the three carriers for the hormones, okay? They bind to the hormone and the hormone binds to them, and they are, we usually remember we need carrier molecule, okay? Always we need carrier molecule. Okay, now, if you remember from the previous lecture we discussed, okay, we said in case of thyroid hormone, the thyroid receptor complex is formed in the nucleus. Remember? Suppose the hormone is produced. Now the hormone comes. Once it comes, it passes through the cell membrane, okay? It passes through the cytoplasm. It goes inside the nucleus. In the nucleus, it finds its receptor. So the receptor for thyroid hormones is present where?
Nucleotide.
In the nucleus. Hormone receptor complex is formed in the nucleus. Once the hormone receptor complex is formed, it goes and binds to HRE, hormone response element. Okay, and then we find. I hope do you remember from the previous lecture? Yes.
Yeah.
Students who were not there. Did you understand what I said? Or should I?
No, we understood.
You know?
Mm.
Okay. So
Correct.
hormone receptor complex is formed. Where is it formed? Hormone receptor complex for thyroid hormones is formed in the nucleus. So the complex goes and binds to HRE, hormone response element. It binds over there, and then we have synthesis of mRNA, and then we have synthesis of a new protein. Very, very important, okay? So this is what you can see over here. Now, okay, now the thyroid hormone is very, as I said, it's a very important hormone. It is important for growth differentiation, sex and mental development. Also, it regulates the speed of metabolism. One of the most important effects of thyroid hormone is on its effect on metabolism, body metabolism, okay, which is very important. Okay. Now, the hormones which are produced, they can affect, okay, for example, in protein metabolism, you want to see it causes protein decomposition, on lipid metabolism decomposition, and also oxidation of the lipids. It can accelerate the absorption of carbohydrates, okay, in the intestine, decomposition of glycogen, so the level of sugar can rise in the body. Okay, if we've got large amounts of thyroid hormone in our body, it uncouples respiration and phosphorylation. That means it acts on the mitochondria, okay, on electron transport chain, okay. So if we've got thyroid hormone in large amounts, the abnormal amounts, what happens? It uncouples respiration and phosphorylation. So what happens? There's a decrease in the amount of ATP synthesis, but large amounts of heat is produced. Very understood? So, what does thyroid hormone do in large amounts, in excess amounts? What does it do? It uncouples phosphorylation and also respiration. What happens? ATP is not produced, but what is produced? Heat is produced. That is the reason that when a person is suffering from hyperthyroidism, that means large amounts of thyroid hormone is produced in the body, the person feels hot, okay, but no energy, because ATP is not produced, because it's uncoupled respiration and also phosphorylation. Is it clear? So the level of ATP is decreased. Heat is increased. You feel hot, but you feel tired, okay? There's no energy in the body, okay? No energy in the body. Okay. Okay. Let's go to hypothyroidism. Hypothyroidism is what? You do not have enough hormone in your body, okay? Hypo. You do not have enough hormone in your body. It can be either primary or secondary. When you talk about primary, that means there's a problem with the thyroid gland, okay? And there's not enough iodine in the, for example, in your food, in the soil. Usually most of the people who are hypo, they are iodine deficient. That is the reason that in the salt, okay, that you eat, usually what they do, they put some iodine, okay? Usually they do it, the governments do it by themselves, okay? Because to avoid hypothyroidism. So either the problem is with the thyroid gland or is with the iodine deficiency, okay? Okay, when we talk about secondary is either at the hypothalamus level or at the pituitary gland level. That means something is wrong with TRH or something is wrong with TSH, okay? Okay, now, how about hypothyroidism in children is known as cretinism. So very important. So hypothyroidism in children is known as cretinism. Cretinism usually is hereditary, okay? And children, babies are born with hypothyroidism, and the thing is that usually what happens when the baby is born, what happens? A child specialist checks the baby, okay, that everything should be correct. That means they check the thyroid gland, they check the ear, the eyes, everything, they check everything. They know how to do it, of course. But the thing is that if sometimes it slips or they do not check it properly, okay, and the baby is hypothyroidism, the baby will suffer from cretinism. It's not a very good thing. Okay, we'll check it, we'll see it together as well. In adults, hypothyroidism will give rise to myxedema. Okay, myxedema.
These primary or secondary diseases?
Yeah, what we're talking about.
But are they classified as primary hypothyroidism?
Usually this is we talk about the gland, okay? The problem is with the gland.
So it's primary.
So
it's with the gland, so it's primary.
Oh.
Okay, it's primary. Usually we talk about the gland. The problem is usually with the gland, but it can be, the effect can be from TSH or TRH as well.
Oh, okay.
They have to first find, okay, what's the reason, whether the baby is hypo or not. Okay. This is a person, okay, who's suffering from myxedema. Okay. If you do not take, okay, the hormone, okay, if you do not have enough hormone in your body, say for 1 month, okay. After a month, okay, what happens? Everything swells. The hands are swollen, the face are swollen, the legs are swollen, it becomes dark, okay, the skin turns dark. Okay, there is a decrease in the metabolism, decrease in body temperature, and the thing is that when you do not have the thyroid hormone in your body, you don't feel like walking, you don't feel like talking, you don't feel like doing anything. Okay, you feel so weak and so fed up with life. Okay, it's a very important hormone, okay, in our body. So decrease in the body metabolism and also decrease in the temperature, body temperature, edema. As I said, you feel weak, you feel sleepy, you don't feel like walking, talking, anything. No energy at all. Okay, there's no energy at all in the body.
Why is the skin color changing?
You know what happens? The thing is that actually what happens, the body starts swelling. Okay, the body starts swelling, and there's a decrease in the body metabolism. Okay, the skin loses its texture after some time. It turns to dark, you know, like as if it's abnormal skin color. Okay, the body is not in its natural form, I can say. Okay. Okay. Next is cretinism. As I said, cretinism, usually it can happen, okay, in childhood. Some babies are born with problems with their thyroid gland, okay. The thyroid gland does not function well, it's hereditary, okay. Also, sometimes it can be a problem with their food. There's not enough iodine in their food, so they get into trouble, okay? There's a decrease in their metabolism, decrease in body temperature. One of the things that it affects the growth of the person. Why? Because it affects the body metabolism. See, when a person is grown, okay, an adult, if an adult is suffers from hypothyroidism, what happens? It affects the body metabolism, okay? It affects the body metabolism. But you do not need to grow once you're an adult, okay? But when a baby, okay, is suffering from hypothyroidism, what happens? The baby has to have a normal body metabolism for growth. So what happens? It affects the body growth. Also mentally, it affects the baby. Okay, babies are mentally retarded. Okay, they become retarded after some time if they do not come to know. Okay, they do not walk properly. Okay, and we can have mental disorders development. Okay, also the body does not develop properly. So in cretinism, the baby becomes retarded, does not grow well. There's a problem with body metabolism. Okay, there's a body problem with the body metabolism. Okay, see, whenever the thyroid gland is hypo, okay, for example, there's not enough iodine, okay, it's hypo. As I said, there's a deficiency of iodine in the food, in the salt which he or she is using. After some time, the gland starts growing, okay, it becomes swollen, okay, it becomes swollen, and it enlarges, okay, like this, okay, it enlarges. We call this goiter, okay, the gland becomes large. And you know what, the thing is that, suppose, when you yourself, you see yourself in the mirror, since you're seeing yourself every day in the mirror, you might not notice that the gland is a little bit swollen, okay? But when another person looks at you, he or she can come to know that the gland is swollen, okay? So remember, always when you stand in front of the mirror, okay, without touching your gland, always put your head up and check whether this part, okay, is like a ring on your neck, okay? Just always check that it should not be swollen, okay? It's very, before it becomes worse, if you come to know, you can stop it. Understood? So always keep in mind, always check your gland, okay? Put your head little up and check it in front of the mirror. Is it clear? So we call this goiter. It becomes enlarged. Okay. Let's go to hyperthyroidism. Hyperthyroidism is what? Large amounts of hormones is produced in the body. Large amounts of hormone is produced, and our body does not need so much. Usually, hyperthyroidism, mostly it's because of Graves' disease. It's an autoimmune disease. Graves' disease. It's an autoimmune disease. Antibodies are produced, okay, which are very similar to TSH. Antibodies are produced which are very similar to TSH. Okay, what they do, they go and they bind to the receptors of TSH. Okay, and they tell the thyroid gland, produce hormone. Is it clear? So, hyperthyroidism, one of the reasons for hyperthyroidism is what? Graves' disease. What is Graves' disease? It's an autoimmune disease. Okay? Antibodies are produced which are very similar to TSH. What do? They go and they bind to the receptors of TSH and they cause the gland to produce large amounts of hormone. This is very, very common. Okay? It is very common. Graves' disease is very common. And the other one can be some tumors which produce the hormone. Okay? Tumors which produce the hormone. Now, in case of Graves' disease, you know what happens? Usually, I've seen many people, I've seen a physician, okay, that he was suffering from Graves' disease and he didn't know. He himself did not know because he was seeing his face every day in the mirror, okay? And he did not realize that there's some changes in his eyes and everything, which we'll see this in the later slides, okay? And Graves, as I said, Graves' disease is very, very common, very common. When you have too much stress, okay? When you have too much stress, one of the reasons for Graves' disease is stress. Too much stress causes production of antibodies against, it switches on the autoimmune system, okay? Autoimmune system. So body produces antibodies against its own tissues, okay? Against its own tissues. Okay. Now, in case of hyperthyroidism, also we have goiter. Sometimes the gland becomes big. It becomes so huge, okay? And we have hypermetabolism, increase in the body temperature, sweating. The person starts sweating all the time, feels too hot, loses weight, and loses appetite. And one of the things is that you want to check the gland, okay, if it's hyperthyroidism or not, okay? When they put their hands straight, okay, like this, you see tremor, okay? The hands start shaking like this, okay? We call it tremor, okay? So tremor is seen. And another one is exophthalmia. Let's see what is exophthalmia. This is exophthalmia, okay? You must have noticed that sometimes, okay, the eye bulges out like this. It comes out, okay, bulges out. What is the reason? You know, there's accumulation of water, okay, and also fat, they say, on the lid, okay, on the upper lid. Okay, so the eyes, you know, it goes behind, okay, like this, and the eyes bulge out, okay? And this is the thing, okay, that many people, they do not realize this. They never notice, okay, that sometimes it can happen to one eye, sometimes it can happen to both the eyes, okay? And as I said about that physician which I told you, one of his eyes, okay, was bulged up like this, and he didn't realize this because he was seeing himself every day in the mirror, okay? But people who see you, they can come to know that the way you look, okay, the way the person is looking, the face, something is not normal, okay? It's not normal, it's abnormal, okay? The eyes bulge out. Is it clear?
Mm-hmm.
Yes? Okay. So, as I said, water is accumulated over here, okay, a little behind the lids, and this causes bulging of the eyes, which is known as exophthalmia. Exophthalmia. Okay, this is goiter, as you can see. It becomes so big, so huge. Okay. Okay. Now, one of the things that usually in hypothyroidism and also in hyperthyroidism. In hyperthyroidism, sometimes what happens, some nodules are formed in the thyroid gland, okay? Nodular, you know, like this, and the shape of the cells changes, okay? And some nodules are, many people, they have nodules, okay, in their thyroid gland, okay? It is hypo, in case of hypo. Usually, these glands, okay, they should be checked, and the glands should be always checked, especially people who are hypo. They go to the, for example, a person who knows how to examine it, okay? They go, they check it, okay? If there are any changes in nodules which are produced, if they're enlarged or the size changes, okay, they have to remove the gland. It is very important, okay? It can change into cancerous cells, okay? Thyroid gland is one of the glands that can very quickly can change. But one of the good things about thyroid cancer is that this gland, okay, since it is situated, okay, inside a covering for itself, okay, usually the cells, they do not run away from there, okay, to go to other places and cause cancer, okay? It does not spread.
So
It does
there
not
is no
spread.
metastasis.
Sorry?
Metastasis.
Metastasis is rarely seen regarding thyroid gland. So if the physician suspects anything, remove the gland, throw it out, take the pill, okay? So it can be easily, you know, taken care of. And usually after removal of the gland, the treatment is done. 1 or 2 sessions of treatment is done, and just to be on the safe side. Okay? Okay. Any questions?
No.
No? Okay. You want to rest for 5 minutes?
Okay.
Yes? Okay.
More.
No?
More than 5 minutes.
Rest for 5 or 10 minutes.